Overview of the local LLM chat application using DeepSeek R1. This application is a standout demonstration of how to build a powerful, locally hosted LLM-powered chat interface integrated with DeepSeek R1 1.5b and Llama 3.2 latest models. Developed with Roo Code and the Copilot free version, aided by Claude 3.5 SI, the app offers a seamless, feature-rich user experience. The app demonstrates exceptional efficiency in terms of resource usage, responsiveness, and overall design. Additionally, this implementation surpasses a similar application developed with Cursor Pro thanks to Copilot Free, which required no additional cost while achieving superior results. This app, developed with Roo Code and Copilot Free, showcases how free development tools can produce professional, high-quality applications. It sets a new benchmark for locally hosted LLM-powered solutions while remaining cost-effective and efficient. 1. Why this app is better than the Cursor Pro Agents version. Development tools. The app was developed using Roo Code with Copilot Free, a cost-free alternative to Cursor Pro, which required a paid subscription. Despite the free tools, the final product matches or exceeds the quality of the Cursor Pro implementation. Key advantages. Advanced features includes additional model settings, e.g. top P, top K, repeat penalty, for fine-grained control. Real-time status monitoring ensures users can verify server and model connectivity. Optimized resource usage. The app demonstrates efficient CPU and memory usage, providing fast inference with minimal system impact. No additional costs. Developed entirely using Copilot Free, making it an accessible solution for developers without access to paid tools. Dynamic interactions. Supports real-time adjustments to parameters like temperature and max tokens, offering greater flexibility to end users. Improved testing and logs. Clear, detailed logs in both the front-end and back-end simplify debugging and ensure smooth operation. 2. Key advantages for the client. Cost efficiency. Fully functional with no ongoing costs for development tools or runtime hosting. Privacy. Runs entirely on local hardware, ensuring data security and compliance with privacy regulations. Customizability. Easily extendable to include new models, cloud integration, or additional features. Scalability. Can support larger models or multi-user setups with minimal modifications. 3. Prompts testing. General knowledge. Who was the 16th President of the United States? Creative tasks. Write a short poem about the night sky. Technical queries. Explain how blockchain works in simple terms. Parameter testing. Temperature, 0.3 to 0.8. Lower values produced factual and deterministic outputs. Higher values generated more creative and diverse responses. Max tokens, 1,000. Allowed for detailed, longer-form responses without truncation. 4. Logs and operational insights. Llama server logs. The server logs in PowerShell confirm successful interactions. Get V1 models. Lists available models. Get help. Confirms the server is running and ready to handle queries. Post API/generate. Processes user queries with response times between 2.8 millis to 4 milliseconds, indicating fast, efficient inference. Backend logs. The backend app PI logs reflect successful query handling. Post ChatP 1.1 200 OK indicates smooth communication between the chat UI and the API. 4. System resource usage. Screenshot analysis. 2.1. CPU usage. 14% utilization. The application demonstrates efficient use of the Intel i5-1145G7 CPU. Even while processing queries through a 1.5B parameter model, the CPU usage remains moderate, allowing for multitasking or multi-user access. 2. Memory usage. 17.1 gigabytes used. The system comfortably handles the DeepSeek R1 1.5B model, consuming approximately 18 to 20 gigabytes of the available 64 gigabytes RAM. This leaves ample room for other processes, highlighting the model's suitability for CPU-only environments. 2.3. GPU usage 1% utilization. Minimal GPU usage, as the model is running entirely on the CPU. While the Intel Iris Xe GPU could potentially accelerate smaller models, the current setup prioritizes CPU inference. 5. Application architecture. 1.1 Front-end. Chat UI technology stack. HTML, CSS, and JavaScript were used to build a user-friendly, responsive interface. Dynamic updates for interacting with the backend API were handled using JavaScript's fetch method. Features. User input. A text box allows users to input prompts to query the model. Model settings. Adjustable settings for temperature. Controls response creativity, 0.30.8 tested. Max tokens. Limits the response length, default 1,000. top P, top K, repeat penalty, advanced controls for fine-tuning the model's output. Real-time status displays whether the backend server is connected and the selected model, DeepSeek R1 1.5b. Dynamic feedback displays the model's output directly in the chat window after processing the query. 1.2 Backend, Python API technology stack. The backend was built with Flask, a lightweight Python framework. The API acts as middleware between the front-end chat UI and the locally hosted Ollama server running the DeepSeek R1 model. Endpoints. /chat processes user input from the chat UI, sends queries to the Ollama server /API's generate endpoint, returns responses to the front-end, help, and models, verify the server's status, and list available models. Key enhancements. Parameters such as temperature and max tokens are dynamically passed from the front end, allowing users to adjust model behavior in real time. Error handling ensures graceful failure if the model is unavailable or the query is malformed.